Section 2.6, we're going to use factoring to solve polynomial equations and to make predictions with models. In the first section, we're just going to solve some equations. Part B is going to deal with our models. To solve, I need to use the zero factor property. The zero factor property says that if two things multiply to zero, that could be true if either one of them is zero. Then either A is equal to 0 or B is equal to 0. Right? If you're multiplying two things together and you get 0, you can conclude that either one of them could be 0 to make this true. They could both be 0 or one or the other be 0. Okay? One of them has to be 0. So, if I want to solve a polynomial using the zero factor property, I first want to set the equation equal to 0, and then I want to factor it to create a product. And then if either factor is equal to 0, it would become true. If either part was equal to 0, the whole thing would multiply to 0. So let's see how this works in the first two examples. First, get it equal to 0. So I need to subtract the 7x and add the 10 to get everything on the same side as the x squared. We want the x squared to have a positive coefficient because that's going to make it easier to factor. Okay. So I'll have x squared. I need to subtract 7x over. And then I need to add 10 over. Excuse me. Then I have it equal to 0. Okay, now we factor. Check your technique. 3 terms, no GCF. A value is 1, so you can just break down the 10, the last number. 1 times 10 is 10. It's positive 10, so you need 2 of the same, 2 negatives or 2 positives. Because the middle term is negative, it's going to be 2 negatives. Not many things going to 10, so you're left with 2 and 5, or 10 and 1. 2 and 5 are going to work because they add to negative 7. Remembering that this is direct substitution with these values because the only way to make x is with x and x. So I mean, to make x squared, I mean, is with x and x. So I'm going to have x minus 2, and we're going to have x minus 5 equals 0. Now, this product would be equal to 0 if either x minus 2 equals 0. That would make it true, and so would x minus 5 equals 0. So I'm going to set both parts of my factor equal to 0. I'm going to solve them to find my two solutions. So if I add 2 to both sides, the first one is x equals 2. And if I add 5 to both sides, the second one is x equals 5. Either of these numbers would make this product 0. So either of them would make this true. And you can check them back in the original as well. If you do 2 squared, that's 4. 7 times 4 is 14. 7 times 2 is 14 minus 10 is 4. So you get 4 equals 4. And you'll also get the same thing, a true statement, if you plug your 5 back in. In part B, I need to set this equal to 0 first. So my first step is going to be distributing so that I can rewrite this as something equal to 0. So I'm going to have 3x squared plus 2x equals 8, and then you need to subtract the 8 over to get it equal to 0. So 3x squared plus 2x minus 8 equals 0 is going to be my quadratic. Now I need to factor. Okay, so we're going to factor. This has a coefficient A. Coefficient is 3, so I can either use grouping or trial and error. Let's start this one with trial and error. If we get another one in this section that involves this method, we'll use grouping. So the first term, I need to break down 3x squared, and the only way to break down 3 is 3 and 1. So I'm going to start with 3x and x, and then I have several possibilities for my 8. So I'm going to try 2 and 4 to begin. And I'm not going to put my signs in there yet because I know that one is positive and one is negative, the larger one positive, but I'm not sure which product is going to come out to be larger yet. So first, 3 times 4 is 12x, then 2 times x is 2, and if I subtract those, larger minus smaller, that would give me 10x, which doesn't work. So we try again. What if it is 3x and x, but instead of 2 and 4, it's 4 and 2? So this would give me 6x, and 3 times 2 is 6, 4 times 1 is 4, and if the larger one is positive, that would give me 2, which is what I want. The larger one is positive, so that's the outer one. The 3 times the 2 is positive, and then the 4 times the 1 is negative to get the positive 2x. So this factors as 3x minus 4 times x plus 2. That is the correct factoring to add to the 2x in the middle. Okay, so set it equal to 0. Now I want to set each of my factors equal to 0. So 3x minus 4 equals 0, or x plus 2 equals 0, and then solve each of these. In the first one, add 4 to both sides. That would give you 3x equals 4. then divide by 3, and x is equal to 4/3. Second one, subtract 2 from both sides. That's going to give you x equals -2. So the two answers here are x equals 4/3 and x equals -2. The next page. Several more examples I'm going to solve by factoring, and I suspect that we're going to see different types of factoring as I look at each of these. In each of them, my first step is to get it equal to 0. I always want the leading term to be positive if possible, because you need a positive leading term to factor most efficiently. So because the x cubed is already positive on this side, I'm going to move everything to that side. So I'm going to have 2x cubed plus 5x squared. To move the 8 over, I'm going to need to subtract 8x, and to move the 20 over, I'm going to need to subtract 20. Then it would be equal to 0. This one has 4 terms. I know that if I want to factor 4 terms, the only technique available to me is grouping, so I'm going to group. And the first 2 terms have no numeric value in common, but they do both have x squared, so I'm going to factor out x squared. It's going to leave me with 2x plus 5. And the second 2 terms can both be divided by a -4. That's going to leave me with 2x plus 5. The 2x plus 5s are in common. That's my binomial factor. We factor that out. The coefficients are x squared and -4. Not quite factored yet because these still have a quadratic, and that quadratic can still be factored. So you're going to write this as 2x plus 5 and times, remember that factors into x plus 2, x minus 2, those binomial conjugates. There are 3 factors here. Set each of them equal to 0 and solve. So the first one is going to be 2x plus 5 equals 0, then x plus 2 equals 0, then x minus 2 equals 0. Solve each of these. First subtract 5 from both sides. 2x equals -5. Divide by 2. That first solution is going to be x equals -5/2. If you subtract 2 from both sides, the next solution is going to be x equals -2. And if you add 2 to both sides, that last solution is going to be x equals +2. So those are your 3 solutions. Keep in mind that the number of answers that you get does match the exponent in these. So since I started with x cubed, I did expect there to be 3 answers. If I start with x squared, I do expect there to be 2 answers. Okay. In this next one, 1/6 x squared plus 4/3 x plus 5 equals 3. I don't like to factor with a fraction. I've never done it before. So what I would do first is multiply everything by the least common denominator here, which in this case with 3 and 6 is going to be 6. So both sides of the equation, multiply every single piece by 6, least common denominator. 1/6 times 6 is 1, so I'm going to start with 1x squared plus 4/3 times 6. 3 goes into 6 twice, that's 2 times 4 is 8. 4/3 times 6 is 8x. And last, 5 times 6 is 30, and equals 3 times 6 is 18. Get rid of your fractions first, and then simplify and solve. I can't solve until it's equal to 0, so the first or next step is going to be to subtract 18 from both sides. I'm going to get x squared plus 8x plus 12. 30 minus 18 hopefully gives me 12, and then I'm going to factor what I have left. Now, because there is no coefficient of 1, I am just going to grab that last term, which is 12, or think 12 times 1 is 12, and then I'm going to break the 12 down. It's 2 positives, 2 the same, because I need to multiply to a positive, and they both need to be positive to add to a positive 8. So 2 positive things that go into 12. The first thing I think of is 3 and 4. Those add to 7, so close, not there. The next thing that goes into 12 would be 2 and 6, and that does add to 8, so those are my 2. Remember that if they have no coefficient of x, if the coefficient is just 1, they go right into the parentheses. So you're going to have your x with a positive 2, x plus 2, and x with a positive 6, so x plus 6. Set them each equal to 0, x plus 2 equals 0, and x plus 6 equals 0, and subtract to get x by itself. So subtract 2 from both sides, that gives you x equals -2. Subtract 6 from both sides, that gives you x equals -6. Parts C and D. I need to do some distributing here before I can begin to solve, because I need to get my like terms combined so that I can get this all written in one line and get it factored. So first, distribute. 4x times 2x is 8x squared. 4x times 3 is going to be a negative. 3 is going to be negative 12x. Then negative 1 times 2 is a negative 2x. And then a negative and a negative positive 3 equals 3. So I've got 8x squared minus 14x. And I have plus 3, but I'm going to subtract this 3 over to get it equal to 0. So the 3's are going to subtract right off. So really I just have the 8x squared minus 14x. Then you need to factor. There are only 2 terms there, so I only have GCF and my binomial conjugates for my strategies here. So GCF is available. I'm going to factor out 2 and x, since both of these terms can be divided by 2x. Leaves me with 4x minus 7. That's not quadratic anymore, so this can't be factored any further. So I set each factor. The first one is 2x, the second one is 4x minus 7 equal to 0, and then I solve each of these. 2x equals 0, so divide both sides by 2. 0 divided by 2 is 0. 4x minus 7 equals 0. Add 7 to both sides. That gives me 4x equals 7. Divide by 4. That gives me x equals 7/4. So my 2 solutions in this case are x equals 0 and x equals 7/4. Part D, we're going to need to distribute to begin. 4w times w is 4w squared minus 4w times 3 is negative 12w equals w squared plus 4w plus 12. Okay, so to combine like terms, I want to get the positive coefficient of w squared. So I'm going to move each of these terms from the right to the left. So I'm going to subtract each of those over. So 4w squared minus w is going to give me 3w squared. Negative 12w minus 4w is going to give me negative 16w. And last, I'm going to have minus 12 when I subtract that one over. I'm subtracting w, subtracting w squared, subtracting 4w, and subtracting 12. Okay. Now, I need to factor. There is no GCF, so I'm going to have to use, because there is a coefficient, not 1, I'm going to have to use either trial and error or AC. I used trial and error last time, so this time we're going to use AC. Okay, so A times C. 3 times negative 12, that's negative 36. It's negative, so 1 positive, 1 negative, with a larger negative because the middle term is negative. Okay, so we'll start saying what goes into 36. 6 and 6, which isn't going to work because 6 minus 6 is 0, so try again. 36 is also 9 and 4, larger negative, so negative 9 plus 4, that one would give me negative 5, not giving me 16, so I'm going to keep trying. 36 is 3 times 12, so negative 12 plus 3 would give me negative 9. Doesn't work either. 36 is also 2 times 18, so if I have negative 18 plus 2, negative 16. It took me a few tries to think of this combination. So that's going to be the pair that's going to work. It gives me the negative 16, so I'm going to separate that into 3w squared. Instead of the 16, we'll have negative 18w plus 2w, and then the minus 12. I can't quite fit the equals 0, but it's, imagine it there at the end, equals 0. Okay. Factor by grouping. Now that you have 4 terms, you created your 4 terms so that you could group. The first 2 terms have 3 and w in common. That would factor out and give you w minus 6. Second 2 terms have 2 in common, w minus 6. Hopefully you can read that. And then the binomial w minus 6 is in common. It leaves you with the coefficients, which is 3w plus 2, and now I have room to put my equals 0 back on the end. Set each of your factors, w minus 6 equal to 0, and 3w plus 2 equal to 0, and solve each. So if you add 6 to both sides, the first factor gives you w equals 6. If you subtract 2 from both sides, you have 3w equals negative 2, then divide by 3. The second set of answers is w equals negative 2/3. So you have, I don't have my page number there, but you have w equals 6 and w equals negative 2/3. All right, so I'm going to flip the page to look at a new technique for solving polynomial equations. Instead of solving them by factoring, they can also be solved by graphing. We've already seen that any equation can be solved from the calculator by graphing both sides. So graphing both sides, and so you're going to do y1 and y2, one for each side, and finding the intersection. So we're going to do that to solve each of these. Now, these could be solved by factoring. This one I think was solved on the previous page by factoring, and so is this one. These are actually the last two problems we did. Okay, so we're going to get the same answers hopefully we did on the previous page. We're going to solve both by graphing. Okay, so just a review of this method. It's a great way to check answers on a test or to find them if you really have no other way. So graph both sides. The first side is 4x minus 1. So in my y equals menu, just typing, if I can type right, typing it as I see it. 4x minus 1 in parentheses times 2x minus 3 in parentheses, and then equals becomes my y2, so equals 3. I'm going to hit zoom standard because I had a regression equation in there first, and I just want to see what it looks like in a standard window. Anytime you solve by graphing, you want to include a sketch, labeled sketch. So I'm going to see what it looks like, and then I'm going to draw it. Okay, so I got a good idea right here that this looks like this. And a labeled sketch. So the curved equation is y equals 4x minus 1 times 2x minus 3. The straight equation is y equals 3. And what I want to find are these two intersection points. So going back to my calculator screen, to find the two intersection points, second calculate, second trace, go to the calculate menu, option 5 is intersect. Hit enter for first curve, enter for second curve, enter for guess, and it finds the first point. It says intersection is at 0, 3. Okay, I'm really concerned with the x value, not the y value, because x is what I'm trying to solve for. I knew y was going to equal 3 because that's what I said it was going to equal. So the first point has an x value of 0. Okay, so x equals 0, and it looks like on the graph that has x equals value of 0 as well. Now I'm concerned with this one. Okay, so back into the second calc menu, option 5 for intersect. First curve, enter. Second curve, enter. Before you hit enter and guess, you got to get it at least halfway to the next point. So now it says intersection is 1.75 for this next x value. So the x value here is 1.75. So those are my two solutions. Let's compare this to what we got on the previous side. Remember that we just solved this one by factoring. We solved this one by factoring, and we got x equals 0 and x equals 7/4. 7/4 is, in decimal form, 1.75. It's 1 3/4 or 1.75. So the same two answers, we can get them by factoring, or we can get them graphically. So it's a great way to check answers, or to just get answers if you really couldn't figure out a way of getting them any other way. Okay, we're going to do this once more in part B. Okay, in part B, I need to graph the first equation. You always have to use x instead of the variable shown, but we're going to do 4x times x minus 3, close parentheses, enter the next equation, x squared plus 4x plus 12, and we're going to graph. Let's make a quick little sketch of what our graph shows us. So I see an equation like this, and okay, so I'm going to have to change my scale right here. My other equation looks like this. Okay, so the low equation, the blue equation, is y equals 4w times w minus 3. And the upper equation is my y equals w squared plus 4w plus 12. Now, I can't see that much in my graph, but because I know what a parabola looks like, I know that this parabola is going to intersect once here. It's going to continue up and eventually intersect this one again over here. Okay, so I need to change my window so that I can actually see those two values. So I'm going to make my window a lot taller. It doesn't need to be wider, it just needs to be taller. So I'm going to change the y maximum value to, I'm going to try 50, it was 10. I'm just going to make it quite bigger and let's see if I made it large enough. You can't find intersection values unless you can see them on the calculator screen. Let's see. Definitely see the first one. I'm not sure if we really see the second one yet. I cannot, but I'll go ahead and find this one first. So second calc, option 5, intersect, enter, enter. Guess it's already pretty close to that one, so we'll hit enter. So that first one is x equals negative 0.667. Okay, if you know the decimal for that is the same as the fraction negative 2/3, you can write it as negative 2/3. I forgot the negative there. Negative 0.667 is the fraction 2/3. Let's get that y value up higher to find the next one. So window 50 wasn't high enough. Let's try 100. And then I'll have to graph it again and see if I can see the intersection on my screen. Okay, let's see. Here comes the one at negative 2/3 again, and the other y value. Good, I can see it on my screen. So second, calculate option 5, intersect, enter, enter. For first curve, second curve, and for gas, you have to get at least halfway there or it'll just find the other one again. So this one comes out to be 6. Okay, so my answers are x equals negative 0.667 and x equals 6. I know that's negative 2/3 as a fraction. Okay, let's flip back to the other side. Remember that we just solved this equation. Let's see if we got the same answers. X equals 6, x equals negative 2/3. Those are the answers we had by factoring. They are also the answers that we can achieve from graphing. A little bit more work to get this one to graph though, because those values didn't show up originally in the graph. I really changed my window a few times to be able to get that second intersection point to show up. Okay. A few more. Example 4. Solve the equation by hand and by graphing, including a sketch. What are the solutions in relation to the graph? Okay, so first of all, by hand, I'm just going to factor. It's already equal to 0, so that's pretty cool. So I just want to factor. So I want to grab the negative 8 because the coefficient of x squared is 1, and then see what goes into it that's going to add up to negative 2. First of all, it's negative, so you need a positive and a negative with a larger negative. So negative 4 plus 2, right? Gives you negative 2. Coefficient is 1 again, so you can go right into the parentheses, x minus 4 and x plus 2. That's how this factors. Then you can each factor equal to 0, x minus 4 equals 0, x plus 2 equals 0. So if you add the 4 to both sides or subtract the 2 from both sides, it's going to give you x equals positive 4 and x equals negative 2. Those should be your two solutions. We're also going to find those two solutions graphically. Okay, so back into y equals, clear up the previous equations. This one is x squared minus 2x. Oops, wrong button. Nope. X squared minus 2x minus 8. And this time, instead of it being equal to 3 or equal to another function, it's equal to 0. So I'm not going to put anything in y2. I'm just going to graph. I better change my window though, because I had the window from part B in the previous example. So as soon as it finishes, I'm going to hit zoom standard. Zoom option 6 is zoom standard to go back to the standard window. Okay. I'm looking for where this equation is equal to 0, and you can see it. You can see it's equal to 0 here and here on your graph. And to find those places where it's equal to 0, I don't need to do intersection. I just need to find the zeros, which is option 2 instead of 5. The questions here are left bound and right bound. So you have to go to the left all the way past it. So you're on the left side, hit enter, then pass it again. So you're on the right side, hit enter, and then just hit enter again for guess. You can get the first one is at negative 2, which I expected. And the next one, find the next 0, option 2 again for 0. Go towards it, stay on the left, hit enter while you're still on the left, and then go past it on to the right, hit enter, then hit enter again for guess, and you got your 4. So again, you can verify those two values graphically. Different set of buttons than for the previous ones. I don't use intersect. If it's already equal to 0, I use the zeros button instead. Last part, what are the solutions in relation to the graph? These solutions are the x-intercepts. Right? And the x-intercepts are also called the zeros for this reason. The x-intercepts or the zeros, two words to the same thing. Okay. Note, when one side of the equation is equal to 0, then the graph of that side, y equals 0, is the x-axis. So the intersection points you're really finding are the x-intercepts, just summarizing what we said from the previous page. Okay. So if I have a question, like example 5 right here, that just asks me to find the x-intercepts, They're asking me to find the x-intercept. That's a different way of telling me to set the equation equal to 0. Find the x-intercepts. That means take the equation 4x cubed minus 12x squared minus x plus 3 and set it equal to 0. We're going to do this by hand, and then we're going to verify it using our calculator, getting the same answers. 4 terms, so I know that when I do it by hand, I'm going to factor by grouping. The first terms can both be divided by 4 and x squared. It's going to leave you with x minus 3. Second 2 terms, the leading term is negative. You always factor out a negative. Divide that by negative 1. It leaves you with x. Positive divided by negative is negative, x minus 3. Okay, so the binomial in common is x minus 3. The coefficients give you the new factor of x squared, 4x squared minus 1. So quadratic term, that quadratic term can still be factored because it is a difference of 2 squares. So it's going to give you with x minus 3 and a, 2 times 2 is 4, so a 2x plus 1 and a 2x minus 1. Those binomial conjugates. So you have 3 factors, set each one equal to 0. X minus 3 equals 0, 2x plus 1 equals 0, and 2x minus 1 equals 0. The first one, if you add the 3 to both sides, gives you x equals 3. If you subtract 1, you'll have 2x equals negative 1. If you add 1, you'll have 2x equals positive 1. And dividing by 2 is going to give you x equals negative 1/2 and x equals positive 1/2. So my 3 answers here are x equals 3, x equals negative 1/2, and x equals positive 1/2. I should be able to verify this graphically. Go back to y equals, graph the equation. It is 4x cubed minus 12x squared minus x plus 3. I'm going to make sure I'm in a standard window by hitting zoom standard. And let's wait for our graph. Okay, it's a little bit low down there, but I can see that this is the general shape. And the locations that I'm looking at, I can see clearly because I'm looking for the x-intercepts, the places where my graph crosses the x-axis. I'm going to find the zeros. Second, calculate. Option 2 for 0. I'll find the one over here first. So I go on the left side of it, hit enter. Go back to the right side of it, hit enter, then hit enter again for guess. That first one has an x value of negative 0.5. That's the first one, my negative 1/2. Then second calc again, option 2 for 0. Stay on the left side, then hit enter, then go past it, hit enter, and then find it again, 0.5. That's my next one. I knew 1/2 was going to be my next one. And last, second calc, option 2 for 0. Go close to it, but stay on the left. Oops, I passed it. So just go back to the left side, hit enter, then go to the right side, hit enter again for guess, and you get 3. So you can see your 3 zeros. You can also find them graphically. Okay. The back side of this page just has some directions for how to use the calculator to find those zeros. So if you had any questions while I was using my calculator, we've got a summary here. We graph it in the y equals menu. We graph. If necessary, you can change the window or zoom standard. And then second trace goes into the calculate menu, 2 for zeros. So just kind of going over that process. And that is the end of part A.